third lecture. In continuation with the previous sessions, I am going to handle the topic that is sustainability in additive manufacturing. So earlier we have seen what is the procedure for doing the manufacturing technique. How can we able to convert the design into the prototype? What is the in-between stages between design and the prototype? How can we list it out there, functional stages, and how can we execute the functional stages with the help of CAD model, and how it was very good compared to the conventional manufacturing, in what ways the material can able to contribute for high performance. So these are the things which we can see in my previous sessions. So in continuation with my second lecture, I am going to speak about the sustainability for this session. Okay, so generally sustainability means whatever the material which we can use, it can be permanently available in the earth. We don't need to worry about their material, the materials demand, because in the earth we having so much of materials. It is able to recyclable, and also we can able to use it for any case. Okay, so there is no problem about their material usage, and here we having a minimum material waste, and majorly we are using the recyclable materials for the 3D printing, and most often we use it to make it as an energy efficient when it is compared to the subtractive methods. For example, the good example for subtractive methods, if I am going to do any kind of milling operation or shaping or planing, these are all coming under the category of subtractive methods. But in case of additive manufacturing, the subtractive methods, we are using the materials which it can be recyclable, and it can be reused for the manufacturing. The good example which you have seen, the first one, we are using the PLA as the reference, that is polylactic acid, and following that the 3D printing waste has been heated over that PLA corona makers. So based upon that, we use it to washing their materials and shredding the materials into minute particles, and according to that, that filament has been winded, which you have seen in this screen. That filament winding, it can be done with the help of wet photopolymerization, and according to the wet photopolymerization, it can be extruded with respect to the compression molding. This compression molding, which it helps to transfer the characterization, and also it can able to perform the testing methods with respect to the type of material which you are using in the particular manufacturing technique, and it can be keep repeated with the help of the viscometry, and as well as the recycling process, and that shredding and extrusion, which can keep repeating their process to carry out their fundamental manufacturing technique. So this is the basic process which we are using for the material identification and the material usage for the additive manufacturing processes, and most often it can be used for the energy efficient performance with respect to their customer requirement. Okay, and for what about the stages of ideate? So since I just discussed about their fundamental manufacturing technique, and how the material can be reutilized, and how the material wastes has been eliminated. So based upon that, how can we ideate the process? So that is an important thing. So here in this screen we just see the first, we have to make it as an idea. That idea can be drawn in the by using the 3D model software. From the 3D model, that component is coming under the slicing category, and in that slicing category, once the component has been readed well, their structure, their points, and their major lattices point, once it can be readed by the slicing software, and it can giving the command to the filament winding and the resin. The filament will start feeding over the machine, which can keep running with the help of one mechanism, and the resin also parallelly it can able to ignite the performance. That filament has been getting melted, and so that both the filament and as well as the resin, which it can be transformed, and following that the part will start manufacturing. Okay, once the part has been start manufactured, the final post processing work will be done. So that is what you have seen in the screen at the bottom of the slide. Okay, so based upon that, we are preferring that 3D model and slicing one with the help of the post processing technique. We use it to manufacturing this process in various different ways. In industrial application, if I since we are already told majority of the lightweight application we prefer the additive manufacturing because the material cost involved in this manufacturing is very less, and also the manufacturing involves it doesn't need so much of skill to make the complicated shape, because since it can use it to make like a light applications like turbine blades, propellers, and chassis, and as well as the bumper device, and also that body of the vehicle, and flight wings, and human tooth, and along with that in medical implementations or medical installations it can be used. So majorly the bone manufacturing. So these are the areas which they are usually we need to manufacture in the components in that way. Okay, in specific, if we speak about in aerospace, engine components and brackets are the major components which can be manufactured by using the additive manufacturing. And following that, in the automotive products, if we are going to speak, jigs, fixtures, prototypes, these are the major applications area which we can done by using the additive manufacturing in the automotive production. And if you are speaking about the medical, implants and prosthetics, tooth, bones, and skull, and also some kind of hand prosthetics, and these are the devices which we usually we need to make for the medical applications. And if you're going for the consumer goods, preferably the electronics and wearables has been used. In the consumer goods, majority of the electronic devices like resistor, capacitor, diodes, and also circuit board, all kind of manufacturing has been done with the help of the additive manufacturing, so that the electronic devices will keep working with the long lasting condition, and it can able to operate at any kind of temperature areas of application. So that is why the industrial applications has been preferred. Okay, and remaining we will see in next class, and thank you so much for your patience listening.